Hello students, today we are going to start with the rational numbers as you can see, and I think this is the first chapter of your book for class 8 and 9, and if I'm not wrong for class 7 also. So you'll be getting many hints and much help from this chapter. So let's get started with the rational numbers. Okay, now as you know, rational numbers can be expressed in the form P by Q. Yes, right. I have written that rational numbers can be expressed in the form P by Q, where Q, that is the denominator, cannot be 0. Now, next part is we have some of the properties of rational numbers. Rational numbers can be either positive, can be negative. So, if we see which are the positive rational numbers, let us write down some of the examples of it. Right? So, these are the positive rational numbers. 1 by 2, 2 by 3, 3 by 5, etc. It can be 73 by 105 and so on. Whenever the numerator and the denominator, the digits, are positive, those two rational numbers or those forms are known as the rational numbers. Okay? Next. The rational numbers where you can also add on with for the rational numbers which we have either the denominator or the numerator, any one of them negative, we call those as negative rational numbers. Okay, so let me repeat this part once more. Suppose if both the digits of the numerator and the denominator both are positive, those rational numbers are known as positive rational numbers. And for those integers or for rational numbers where anyone, either the numerator or the denominator, are negative, either of them are negative, we call that as negative rational numbers. Now, coming up with equivalent rational numbers. We can get equivalent rational numbers by multiplying a non-zero integer. Now, let's start with equivalent rational numbers. We are going to get equivalent rational numbers by multiplying a non-zero integer with the numerator and the denominator of a rational number. Let's see one example. It will be clear to you. Two by 3 is a rational number. So, let us multiply another 3 with the numerator and the denominator. So, the answer that we get is 6 by 9, which is again a equivalent rational number of 2 by 3. Here, consecutively, we can get many other rational numbers, the equivalent rational numbers, on multiplying with different non-zero integers, both in the numerator and in the denominator. Take for example another. This 24 by 36 is again a equivalent rational number of 2 by 3. Okay, so whatever non-zero number, integer, you are multiplying with the your numerator or the denominator will give you this equivalent rational number. Next, coming to how to write rational numbers in standard form. Now, let us take a rational number which has the denominator negative. So, let us take the example as so this is again a form of negative rational number. We want to convert that into standard form. Now, what is the criteria of the standard form? That we have to get the denominator as positive. Okay, we have to get the denominator as positive. I hope you have heard my repetition. So for this, how to convert this denominator negative into a positive? Just by multiplying with -1. Both in the numerator and in the denominator. So here we get the result after multiplying -1 to it, we get -3 by 11. So this is the standard form of a rational number. Next. So our next topic is how to compare two rational numbers. Let us take two rational numbers. So 1 by 2 and 3 by 5 are two rational numbers. Now we are going to compare these two rational numbers. So what are we going to do first? We are going to take the LCM of this denominators. What are those? 2 and 5. So LCM of 2 and 5. So the LCM of 2 and 5 is 10. Next, we have to multiply a digit with this 2 such that we get the denominator as 10. So what is the number with which this denominator 2 can be multiplied to get 10 as a result? That is 5, right? So we are going to multiply this 5 in the numerator also and we get 5 by 10. Next, 3 by 5. We need the denominator here as 10. We have 5 here. So with what number shall we multiply so that we get 10? So you can simply get it by 10 divided by 5, that is equal to 2. So we have 2 here. The same number or the same integer will to be multiplied in the numerator, 2. We get 6 by 10. So the comparison shows that 3 by 5 is greater than 1 by 2. You can easily understand 6 by 10 is greater than 5 by 10. So we can find out that 3 by 5 is greater than 1 by 2. I hope I'm clear to you. Coming up with the properties of addition for rational numbers. The first property is closure property. Now what is closure property? Suppose let us consider two rational numbers, a by b and c by d. Now these two rational numbers, whenever added, will give you another, the result of the rational numbers, these two rational numbers will give you another rational number. Okay, so this is what is closure property. Okay. think you can read it from here. If A by B and C by D are rational numbers, their sum will also be a rational number. So let us take one example. As you can see here, 2 by 3 and 4 by 5, both of these are rational numbers. Let us see what their sums comes up to be. 3 and 5, their LCM will be 15. So, it is 3 5s are 5 2s are 10 plus 5 3s are 3 4s are 12. You are getting 22 by 15. Right? So, this is also a rational number. So, we can say addition for rational number is a closure property. Next property is commutative property. Now, what is commutative property? The basic law of commutative property is, suppose okay, let us see by an example. What is the answer of 1 by 2 and 1 by 3? Check it out. By 6, right? Since 1 by 2 and 1 by 3 both are rational numbers, their sums comes out to be 5 by 6. Now let's see the other way around. That is, let us first take 1 by 3 plus 1 by 2. Check out these results. LCM will be 6. We get here 2 plus 3. That is, we get 5 by 6. So as you can see, both the results adding the digits or the rational numbers in the reverse way, the answers remains the same. Okay, by adding the rational numbers even in the reverse order, the answers remains the same. So this particular property is known as commutative property. Next, coming up with associative property. What is the formula of associative property? Now, this is the particular law of associative property. Let's take an example. Find out the addition of these. We know due to BODMAS rule, we will be first solving out the bracket first. So what is the answer of this? As you know, we have done it before. It is take out the LCM of 6 and 4. Check out the answer of this portion now. As we know, we will be working out with the brackets first. LCM is 12 here. Results comes out to be the same, 13 by 12 and 13 by 12. So you can easily understand how addition holds for associative property. Next property of addition, existence of identity. Now, let a by b be a rational number. Now, if you add 0 to any rational numbers, you will obviously get the rational number. So, take for example 2 by 3 plus 0. You get what? 0 plus 2 by 3, that is equal to 2 by 3. So, this is what is the identity of a rational number. Whenever you add any rational number to 0, you get a rational number. Next, fifth property is existence of additive inverse. Now, what is the purpose of this additive inverse? Let us take a rational number. Whenever we take the inverse of a by b, that is minus a by b, by multiplying a minus 1 to the numerator of the rational number gives you an inverse of a by b. Or for example, suppose will give you so negative of a rational number is the inverse of the rational number. Negative of the rational number is the inverse of the rational number. So whenever you add the rational number and its inverse, we get 0. A plus a by b plus minus a by b will give you 0. Example, 1 by 2 plus of minus 1 by 2 is equal to 0. So if asked, what is the additive inverse of a by b? That is minus a by b. Okay, so the results of additive inverse and the rational number gives you 0. So this is the property of existence of additive inverse. Next coming up with properties of subtraction of rational numbers. Now, first thing that we have done in addition is closure property. So are we going to follow up here also. I hope this is clear to you. Now, as we say of closure property, you know that whenever we are taking two negative rational numbers, the difference of the two rational numbers will also be negative. So let us take again a by b and c by d. Their results will be a rational number. Take for example 1 by 2 minus 1 by 3. The LCM is 6, so we get here 3 minus 2, that is 1 by 6. 1 by 6 is again a rational number. Now, next. Okay, now for the subtraction, we don't follow the law of associative, law of commutative property, as well as identity and inverse. Just have a look on the board. You can easily understand why we don't follow commutative or associative property. Okay, now whenever you are subtracting two rational numbers, and the reverse is also subtracted, we don't get the same results. As for example, 1 by 2 minus 1 by 3. The result is, you know the LCM is 6 here, we get 3 minus 2, that is 1 by 6. Again, 1 by 3 minus 1 by 2, we get 2 minus 3, that is minus 1 by 6. You can easily see that 1 by 6 and minus 1 by 6, the results are different. So, for subtraction, if we reverse the digits and subtract it, the results are not the same. Same follows for your associative property, and for your inverse property, there is no existence of any inverse. Rather, it gets added up. Just take for example for the inverse. Let's take a by b as a rational number. So inverse of this will be what? Minus a by b. Now, if we are applying for the subtraction property of inverse, we will get a by b minus of a by b, that we get as 2a by b. You can easily see that this number, that is a rational number, gets twice the rational number. Okay, so there is no follow-up of inverse here. Now, if you talk about identity, let's take a by b minus 0 will give you a by b, but 0 minus a by b will not be equal to a by b, right? What is the answer for this? The answer is minus a by b. So you can easily see that the identity for a by b minus 0 is not same as 0 minus a by b. So the identity of subtraction does not exist. So these are the properties of addition and subtraction. We'll come to with some of the examples from these two properties. Suppose the first question that is given to you, what should be added to 1 by 3 to get 5 by 7? Now let's take the sum here. This was the question, what should be added to 1 by 3 to get 5 by 7? So let the number to be added be x. X plus 1 by 3 is equal to 5 by 7. So x equal to 5 by 7 minus 1 by 3. That is, you get 21 as a LCM. We get 15 minus 7, that is 8 by 21. I hope this sum is clear to you. Doesn't have so much toughness in this. Suppose the sum that is given to you is 1 minus 2 by 7 plus 4 by 5 plus 1 by 3. So at first what you can do is, you can simply add up and then subtract. Okay, that can be quite easy according to the Bottomless rule. LCM of 5 and 3 is 15. 5 3s are 3 4s are 12 plus 5 minus 2 by 7. Next, 15 plus 12, 27 plus 5, 32 by 15 minus 2 by 7. Now, what is the LCM of 15 and 7? That is 105. You can check it out in your notebook if you are having one. That's 105. 32 into 7 is 224 minus 7, 15, 15 2s are 30. So you get here 4, 194 by 105. Okay, so is it clear to you all? So these are the particular small type of sums which comes after the addition and the subtraction properties. So next class we will be continuing with the multiplication and the division properties. So if you are having any doubts till here, please you can write it down to us so that I can answer you back. And if there is any hearing problem, whatever sorts of problem you can having, you may write it down to us so that we can serve you much better. So stay well and stay with us. Thank you and have a nice day.